and we'll come to this revision.
عليكم السلام دكتور.
About the topics that we have covered. And in fact, we will go through the possible questions. We will check the possible questions, and then we will see what are the information that we need to write about these questions. So if we check from the beginning, let's see the topics that we have. I will start by sharing my screen. Okay, and I will use the Paint where I can write and draw. And we will see the topics.
Doctor,
yes.
Can we record the review?
No. And the review I don't record. The student need to take notes if he is interested. So, and I am not allowing the record, okay? We have been recording during the whole semester. It is now time to take notes. And I do believe that writing is better than just looking to the system, okay? So one of the important questions that is coming, the root locus. Okay, root locus is an important topic, and it's included certainly in the questions. So what we will have, basically, what we will have, can I use this? I don't know, for an unknown reason, I cannot use, let's say, the whiteboard. Can I use the whiteboard? No, I cannot use with the screen. Working area. Ah, okay. Good, now it's okay. Yes. So there is a question coming about the root locus. Okay, what I will have? Center, and angle of asymptote. Angle of asymptote. Okay, we have the rules how to find the center, and we have the rules how to find the asymptote. I will ask for breakaway point that you need to find dk by ds equals 0. How you find this? You have 1 plus kgh equals 0. It means k equal 1 over gh. There is no problem if you would minus or if you don't want, because you will take the derivative and you will equal it to 0. It's okay. Okay, then we said we have this one, we have this one, and we have what? We have intersection with the imaginary. Intersection with the j omega. And we have the plot. I ask you at the end to plot the root locus when k is changing from 0 to infinity. Okay, good. So what is the difficulty in this? There is no difficulty, you need just to practice. There is one more thing, you need to know the rules. So for the rules, listen to me. I will make something practical for you. Students are asking for the rules, and you know rules are different from one to another. Do you agree with this? What I can write simple for me, maybe it will not be clear for the other students. Is this clear? You agree about this?
Yes.
Are you with me?
Yes.
So I have an idea that each student, let me open the Word file so it can be written. So it can be written easily. Control N, new file, put it here. Each student is allowed to bring A4 summary paper. So you need to bring A4 paper. Okay. The condition, the name of the student and ID must be written in pen on the top of the paper. Okay. Student name and remove this. And name and ID. Name and ID must be on the top of the paper. Is this clear for everyone? Students, is
Yes,
this clear?
clear.
Yes, because someone will say, okay, this is my paper. I will find another paper with another one. This is not allowed. So you write your name and you are responsible. If it is found with another one, it will be considered as a cheating. And this paper, it can be written or printed or both. Suppose I take rules, I take images, I put it here. I will follow it. Okay, remove the margin. Remove the margin. Okay, take the maximum of the paper, no problem. Paper without margin. Make it printed and handwritten. It's okay, both sided. Okay, but one page only. I call this summary. Summary paper. Paper. Written, printed, whatever, but your name should be here with your ID on the top. Good, both you can, it doesn't matter. Okay, good. So you can write these rules. You know that you will use it. You write it in a simple way. In a simple way. Okay, there is a question coming on that. You will know there are something that you don't need to write. For example, root locus is moving from pole to 0. This is pole and this is 0. That we know. Root locus is located to the right. Is located to the left real odd root. It's okay. Root or pole, that we know. These things are basics. You don't need, you need to write these, for example, rules, center and angle if you need. Okay, intersection with the imaginary, that you know very well. Good. This is a question. This is a question, and it will be a good question. Okay, it will be about 8 marks on this one. 8 out of 40. About. So you have interest to study. If you want to start with important thing, you can master this one. It is not difficult. We have already solved many examples, and I gave you the MATLAB code. Okay, suppose a student is saying, doctor, it is midnight, I don't know where to go, I cannot solve it. You can write here in the you can search the code. I already shared it with you, right? I already shared the code, and you can also write root locus GUI, graphical user interface. You write MATLAB. And there is one site also is doing this. I will call it RLGUI. This one. There is one website that you can, this one, I have shared it with you. You come and you run here, this one. You define your numerator and denominator here. And you will find everything. You have this, or you want the link? I already shared it with you. If you want, I can give it in the chat box. Here you give your numerator, here you give your denominator. And just if you click here, it will show you where is starting, where is the end. And this is going, where is the breakaway, how to find the breakaway. Okay, you have here a breakout, and you can find the points here.
Doctor, can you send it again in the chat, please?
Okay, with the pleasure. This one, Control C. This one. Okay, if you have S to power 2, different polynomials, whatever, you can write it here. Okay, this is good. We have finished. So this is, let we say, a method to find any question, any example. If I will make it here S, for example, I put here enter, I click here, it will be changed. Now I have only one 0 at S equals 0, this one, and I have 2 poles. So this is the root locus to the left of real odd. There is no breakaway because there is no intersection. No intersection, it will be here with this one point at infinity, at k infinity. You go and you change this. Okay, you change this, you make it S square minus S minus, put it 5, and here you put, you can put this one S square minus S, whatever, just you click enter here, you will see the possible solution. That's done. Another point now. Another question. I may ask you to find, this is done. I will ask you, for example, you have this system. You remember in root locus, there is a system like this. S, I think S plus the midpoint was, don't know exactly, S plus 10 maybe. I don't remember, suppose. This system, there is a question is saying, find K value so that S equal minus 5, S equal minus 5 is a root of closed loop transfer function. This is the question. Now, how we can make this belonging to the solution? I have this and this, okay? This is s equal minus 10, and this is s equal 0. I want s minus 5. You know, and we agree that if we change k, the roots will change. Okay, good. So what is the k value to get this here? I have two solutions. Listen to me. Solution 1, we call it algebraic. If this, you know the transfer, the condition of root locus. I have 1 plus kgh equal 1. I have 1 plus kgh equal 1. We call this magnitude condition, right? Mag condition. This is the numerator, the denominator. Condition. This is the denominator of characteristic equation. So I have k, I will say k equal what? K equal 1 over gh. K equal 1 over gh. Okay, what it does mean this? Equal poles over zeros, right? Because h is 1. Here I have h is 1. H is 1. If h is not mentioned, it is 1. So this, it's algebraic. Algebraic, what it does mean? Pole over 0. Algebraic, it means the distance. So I can say k equal the product of distance of poles over the product of zeros. Distances, I think, like this. Okay, distances. So I have this one, this point. So this is distance 1. This is distance 1. This is distance 1, and this is distance 2. So it's equal to, this distance is 5. Distance is positive always. And this distance is 5. The distance of 0 is 1. There is no. So what is the value of k? 25. If you put k 25, you will get the breakaway point. This is algebraic. Do you have a question on this? I have numerical. A numerical solution. A numerical solution from this equation. I have k equal what? Distances, poles over zeros. So from this equation, I can say, okay, this means that k. Listen. Let's make it like this. K over s plus 1 equal 1. You know, 1 plus kgh equal 1. You move it minus, it will be absolute. So you will get k equal the absolute of s plus, sorry, 10. S plus 10 when s equal minus 5. Okay. And then I can say that, okay, put in s minus 5, k equal minus 5 multiplied by minus 5 plus 10, and you will get 25. Same. From where I brought this, it is in the condition before the root locus. You will find introduction to root locus. What is in the introduction? We said 1 plus kgh equal 1. So this is intelligent way is to find, I want that my s equal minus 5 is a root of my system. What it does mean if I select the root? Don't forget, if you select the root, it means you will select the performance. Is this clear? Is this clear?
Clear, Doctor.
Good. So root locus we finish. If you master this and this, done. What you need to write for this? Just write this one. Write the condition. What we call this? This is magnitude condition. We have also, if you want, phase condition. It is the angle of KGH equal plus minus 180. Because this equal minus 1, if you take angle of both sides, okay, you have 1 plus KGH equals 0. This is the characteristic equation, right? So if you will take the angle, you will move this KGH equal minus 1. Take angle of both, you will get KGH equal plus minus 1. That's it. Okay. This is why I'm not focusing on recording. Recording what you will understand. This is my own written way. Write it in your own way. Okay. Write it in your own way. Good. We have finished the root locus. And if you master this, you will get about 10 out of 40. This is good. It's a quarter of the mark. Okay, not necessarily, but plus minus.
Doctor, but what we solved in a class, it will be enough. It's okay, right? For the root locus.
I didn't ask you to solve more or less. You know better. I said a review. This is how we solve.
Yes, I know. Okay, doctor.
Okay. You know if you need to solve more or less. That I don't know, because this is changing from student to another. Okay, what else? What do we have also? For example, there is a possibility that now we will move to frequency response. We will move to frequency response. Frequency response. What do we have? I have, listen, just one remark here for root locus. It is for open loop or closed loop we are plotting. What we are plotting in root locus? Huh?
Closed loop.
No, we are taking open loop transfer function, and we will, from open loop transfer function, we will find the closed loop transfer function roots when we change K from 0 to infinity. Because look here, when you plot, come to this system, to the to this transfer function, this is the open loop. But this, it will show us the roots of closed loop. Okay, so when we take the system, we take the G of H roots, GH are open loop, but only in stability, in intersection with the imaginary, we take 1 plus KGH. Okay, so we are taking the open loop roots, and from open loop roots, here, where is the rules, the rule table or example Y overview? Here there is some explanation. The root locus, it's a very useful method. It will show us the behavior of a closed loop. Okay, but when we change the gain, but what we are taking the open loop. So don't close the loop. If I will give you GH, don't take 1 plus or G over 1 plus GH, and then you find the roots on the plot. No, you take directly. This is also explained. Okay, not the program derivation. Okay, so it's the method to find from the open loop root locus. I think also it can be, you can find the definition easily. The root locus is the graphical representation in the complex plane to find the roots of the closed loop. Yes, we find it, but using the open loop parameters, which are the G and H. We take them, we multiply them together. Okay, so if we multiply, it means we take them as an open. We are not taking them as a closed. It's open loop. Okay. What we have else for this? Now, if we will go to the frequency response, also we take open loop. G. Okay, we take G, the open loop. What we have? I have If I will bring Nyquist, I will give you table, I will give you omega, and I will tell you find magnitude and phase. There is no decibel, only magnitude. So I will give you values, you will fill it using the calculator. You need to know how to program your calculator. Some calculators you can write the equation and you give it a vector, it will find directly the output. You should be familiar with this. If I am asking for, this is Nyquist or polar. Okay. If I am asking for baud only, here you will add decibel. Baud, you will put magnitude in decibel. And this is same, and this is same. And magnitude in decibel equal 20 log magnitude. Okay. We have one point here is the gain margin. Okay, gain margin. And we have phase margin. We find gain margin at phase crossover frequency. We found phase margin at gain crossover frequency. Okay, so on the graph, what it does mean the gain margin? The gain margin, it is the decibel. The gain margin, it is the gain. Suppose this is 0 decibel. This is 0 decibel. And here, I have the angle is 180. Suppose this is minus 180. The angle like this at this point. So at this point, I will see where is my magnitude. My magnitude, suppose it is here. Suppose my magnitude is here. So at this point, I will say this is the gain margin in decibel. It is the added gain that I can put, extra gain that I can put to the system before it comes and it becomes unstable. This is the gain margin. And I found it, what's this? This is this one, I will call it phase crossover frequency. Okay, good. I have also phase margin. You can find when the gain equal to 0. Suppose this one, suppose what I have. Okay. Suppose that you have this one. Why it's not coming as before? Brush, which one it was? Don't know. Okay. Suppose this one is here. I don't know. Suppose this one is here. Here, this is we call phase crossover. What we call gain crossover frequency. This one, gain crossover frequency. So I find the phase angle here. This is not exact, but it's supposed to be something below, so it can be added. So this is a classical way. What is not classical? For example, if I will give you a system and I ask you to find the transfer function. Yes.
Yes. Can you go back to what you written? Just a second. Yes, I will see. Okay, doctor.
This is not correct. This has to be little below, so you can add negative phase. Yes, no, it's okay. It's okay. It's the negative phase that you can add. It's good. It's good. This is the phase margin. This one that we can add. Okay. Good. If I will suppose give you a plot and I ask you to find the transfer function, students should be able to do that. Why? Because we know we have rules. Which one was writing good? Maybe this. Yes. If we have, look, this is corner frequency. This is corner frequency for 0. Okay, it's 20 per decade. At this point, if I have like this is minus 20 per decade. So this is what? This is pole. Okay, if I have minus 40, it is double pole. Okay, it's to the power square. Good. Can I find transfer function for a system? Suppose transfer function for a system. Let's see. Normally we can. Normally we can. I don't know. You want to screenshot something from here? I can give it to you. Why I don't let you recording time is short. Believe me, you will lose if you will see the record. But if you want something from here, I can screenshot it for you. Is it okay? I will erase this. If you want something clear?
Or you, doctor, you write down of the page, then you will take whole screenshot for everything.
No, we cannot, because look, I will increase the resolution and I will keep moving down. Look, I will put here 8. Okay, I will keep moving. Okay, now if I have this system, suppose I have this system, suppose Control V. Where is it? Can I take? How can I select? I have a picture that I want to insert. Okay, Control C, copy. Okay, we'll come here. It's not allowing me. I don't know. Okay, I'll do it in a different way. I'll do it like this. I am here, Control V. I have this system. The question is, for example, what is the transfer function? What is the transfer function? So there is no panic. The question must has a solution. You agree with me? Let's follow these rules. Question, I will write it here. Brush. Question. Is it solvable or non-solvable? Answer me, students. Is the question that I will bring solvable or not solvable?
Solvable.
So yes.
By circuit 2, doctor?
Huh?
By using circuit 2 laws?
No. Don't rush. Is it solvable? Yes. Now, can we solve using given rules are given? Let we say rules. Is it solution rules? Solution rules. Given or not? Now, if it is not given, how can I bring it? I don't ask from other courses. Solution rules, given or not given? Answer me.
Given.
Yes, good. So, not necessarily you will find the final answer, but you can start, right? You can start. Clear or not? Don't jump. The problem, why students, I will tell you the secret, why students are stuck here. Because they did not practice and they want from the first look to find the final answer. This is impossible. They want to find the transfer function from the first look. I cannot find it myself. What we have to do, we have to say, okay, where are the rules? Where are the rules? Put the rules. I have pole is minus 20 decibel per decade. I have 0 plus 20 decibel per decade. I have magnitude in decibel equal 20 log magnitude and equal 20 log zeros over poles. Anything else? Nothing. Only these. Only these. You agree? So I will check here. I will check here. I have a corner. What is this per decade? It is moving from 20. Here I have 40. It is moving from 20 to 40. What is the slope here? Even if I don't write 40, you have this 20 decibel. So this is pole or zero?
0.
This here you have 0. Good. So I have corner frequency. What is the corner frequency? I remember that corner frequency, it gives me 1 plus J1. This is the corner frequency, right? If I have 1 plus S, so this is corner frequency, I should get this. Okay, where is the corner frequency here? This is the frequency. Where is the corner? You remember 1 plus J omega over omega C. You remember this. 1 plus J omega over omega C. This will give me the corner frequency when omega equal omega C. Okay? So what is the corner frequency here? Students.
1 Doctor.
Huh?
1.
1. Very good. So I have 1 plus 1 plus J omega over 1. Or 1 plus S. This is in the 0. This is a 0. Okay? That's it. Any magic in this? No magic. I ask you to plot this. If I will ask you to plot now, say, okay, let me check. Go and plot. When omega equal 1, you will get this one. So you will take the corner frequency. If you know really the corner frequency, you understand, you will say this one. Someone will say this is indirect. Of course, I have to make a difference between students who are deeply understanding and those who are superficially understanding. But however, it doesn't mean that you will get 0. You can start solving something. Okay, this one is okay, done. I will go to the second one. It is moving from 20, now it is 0. It means what I have here, pole or 0. How this is changed? It is moving at a speed 20. Why it becomes 0, the speed? Because there is minus 20 speed, right? So minus 20 is a pole. How can I find the equation of the pole? I can say, okay, this one, I have here 1 plus J omega over 10. This is the, when omega equal 10, there is a corner. When omega equal 10, there is a corner, and this is pole. And so on. I have here another pole at 100. This will be 1 plus J omega over 100. Another pole here. And here I have another 0. I have another 0 at 1000. It's 1 plus J omega over 1000. So the transfer function will be, if I want to write it, it will be S plus 1. S over 1000 plus 1. S over 10 plus 1. And S over 100 plus 1. Okay. Where is the K value? I have K in the transfer function. Okay. What is the value here? Before the roots. What is the value here? 20. So what is K value? 20 log, look, 20 log K equal to 20. So what is K?
0.
No. There is no log for 0.
1.
Dog 1 is 0.
10.
Huh?
10.
10.
10. Very good. This is your transfer function. I selected it to make it simple, by the way. I have made it simple because I want it to be found. So now if you take this and you plot, put it in a table now, and the plot, the body plot, you will find this one. You will find this one. So again, solution rules, given or not given? Given. Given here. I didn't bring something from the external. Look, I said corner frequency, you should understand the corner frequency is here. And this is really giving you a depth of understanding, not superficial. If I will give you, so if you tomorrow you will go to any system, you will see the behavior, you can find the dynamic system. Okay? Good. So this is a possible question. If you find this, for example, you can also now you can find the plot of the phase angle. You put this in the phase angle, and then you can write simply the angle of GH equal. This is, there is no angle. We start numerator minus denominator, so tan inverse imaginary over real omega over 1 plus tan inverse omega over 1000 minus tan inverse omega over 10 minus tan inverse omega over 100. You can construct the diagram, you can find gain margin, phase margin only from this. If you know the rules, follow the rules. Wallahi, I didn't find students who are getting bad performance unless they don't know the rules. It means they did not understand, simply. They did not understand. Put the rules. Don't go right and left and try to cheat someone. They will cheat also, and the other, there is no assurance that the answer will be correct. Why you are looking right and left? Look here, you have a few equations and try to find the answer. Take your time, don't rush. Ask yourself this one. Now, I will tell you again the question. If I will see this, and I will see this, and I try to jump directly to this transfer function, can I do? Me, Dr. Ayman, can I do this? Can I jump to this from this directly without following the rules?
No.
If I cannot, and I am teaching this since about 2 decades, how you can do this? Why you are burning the steps? You want to jump from this? How you can? No, follow this. If you find 2, 3 routes, at least there is some reasoning. Okay? Don't rush. Ask yourself, there is a question there, we have the rules. Okay, good. This is done. Now you have the way to how to solve. Good. What I want sometimes also, sometimes I can give you a system and I ask you to check the stability. Look. This is a question, for example. This is a question, for example. Control V. I will ask you a question. It's another way of asking. Is this system stable or not? Check stability. And why? Check stability. I don't want to make a review for you with simple questions. Simple questions that we know, we have solved many times. You agree with me? We need to see the advanced question. Do you agree, or you want simple questions?
No, we agree with you, Doctor.
And always solution here. Don't think that we are going outside. Always solution is here. I will not bring it from outside. If I will bring, tell me. So I have this system. I don't know, can I make it larger maybe? Again, Control V, I will make it larger like this. Okay, this system, is this system stable or not? Now, how we can check stability? What is this? The topic is, what is the topic, students? What is the topic? Which subject is this? Magnitude in decibel. Huh? Which subject?
Body plot.
Body plot, very good. So this is BOD. Stability in BOD, stability, it means gain margin and phase margin. We don't have anything else. You agree with me?
Yes, doctor.
Stability, it's gain margin and phase margin. Okay, let me see this system. If gain margin is negative, unstable. If phase margin is also negative, system unstable. Okay, where is gain crossover or phase crossover? Where is my magnitude? This is my magnitude. Is it crossing the 0 decibel? No. Right? Is it crossing the 0 decibel?
No, doctor.
No. So that's good. It's not crossing the 0 decibel. So phase margin, like we can say infinity. Now, gain margin. Gain margin, it's at phase crossover frequency. Is it crossing angle minus 180? So I can calculate the gain margin. Where is the angle minus 180? I don't have, right?
Yes, doctor.
So what is the gain margin?
Infinity.
Infinity. So system is stable or unstable?
Unstable.
Why? The system is stable. Why unstable? Unstable if my gain margin negative. I don't have negative. If my phase margin negative. You remember the story of the lift. I have a lift that can take, let me say, 4. Okay. If I have 5 inside, this is unstable. Because how many person I can add? I can add minus 1. So if the margin is negative, it means unstable. It will not go. But if I have here 3 inside, how many person I can put inside? 1. This is stable. I can add.
Doctor.
Oh. Or here, how many person I can add? 0. This is marginally stable. Yes.
Doctor, for the phase magnitude, how did you find that it is infinity?
Because we cannot find here. We said if you solve this using MATLAB, look, this system. If you take any system, I can take this one, for example, 1 over s plus 1. I can find margin. Where is the MATLAB? This is MATLAB. Okay. If you take MATLAB and you put it, I don't know what system is this. Let's see. Here I have positive angle, then negative, then 0. It is numerator and denominator. Okay, fine. If I will take this system, suppose COS. If I write CLC, if I will write margin and I will write transfer function 1, 1. Suppose no, not like this. It has to be transfer function. This one 1, 1. Okay, s plus 1, and I have. This is lead or lag. It is lead. It is lead because here. So this is closer to the origin. So this is far. Okay. I can put 1, 5. Okay. If I will do margin, it will give me the gain margin and phase margin. Look. I have something like this. Gain margin infinity, because it is not touching the minus 180. Whatever you put, it will not touch. And phase margin minus 180. Okay, this will be minus 180. Sorry, because this is a degree. It has to be within this range. This is phase margin is what they said, minus 180. Okay, minus 180 degree. So system is stable because you can see this, the behavior. It is not touching, and we can check this. I can show you. Wait a minute. Go back to the slide, please. I don't have time, but go back to the slide. You will find this also when you solve. So it means system is always stable. Whatever you put K value, it will not touch the 0 decimal. Of course, it has to be positive. It will not touch the 0. Do we have 0? It's at infinity. It's touching. Okay. Clear?
Clear, Doctor. Thank you.
Welcome. Good.
Just one more time, summarize the conditions, please, because I got confused.
Which condition? Which condition?
The infinity, you change it. You put it. You put minus 180.
Here, listen. What is the gain margin? It is the gain that we can add. The gain has to be value, right?
Yeah.
Okay. The angle, it cannot be infinity because it is multiplicity of pi. So the definition in phase margin, I can get the additional angle that I can add to reach minus 180. So if we can say this is 0 minus 180, it means I can add the maximum capacity, which is minus 180. Okay, it cannot be infinity in angles. This is the only point. We cannot make infinity degree because it is cyclic, right? It is cyclic. So we are concerned about the minus 180. So it means that we can add the full capacity, which is minus 180. Okay. Good. Now, the remaining things are simple. The remaining things like what? I will give you a system. Okay. I give you a system like this system. Students asked me about how to find the error. Where is this one, the compensator? Let me just check in the PID or controller. I got many questions about this one. The compensator. Students are asking me how to design a compensator and to make it 10 folds error, this one. Okay, students asked me how to design. Look here, this is a possible question. Listen, this is a possible question. Find the error. What is this? Type 1. Type 1, it is ramp. Okay. So ramp KV equal G when S approach to 0, and I have to multiply by S. So KV equal, remove this, you will get 45.8 over 7. So E steady state equal 7 over 45.8. The question is design compensator to improve the error by 20. Improve the error by 20, it means it will reduce it by 20. So a new error equal 7 over 45.8 multiplied by 1 over 20. Okay, this is the new error. So I need to add a block. The block, I have S plus 0 compensator over S plus pole compensator. Lag, where is the lag? Lag, it means this is closer to origin 20 times. So okay, let this one equal, we have solved here. Where is the realization? And the realization, we didn't assume, we have 3 equations. 3 equations. Students are asking me, Doctor, what we do? We have two unknowns, 1 equation. Okay, we didn't solve this before a few slides. 3 equations, 4 variables. R1, R2, C1, C2. Okay, so we assume this one and find the remaining. This is the assume selecting. So likewise, I will go here. Let ZC equal, I will assume this one 0.2. If this is 0.2, this has to be 20 folds less than. Okay. Or I will assume this and this one, it will be 20 times. Okay, this is easier. So I will assume my pole equal 0.01. So my 0, it will be 20 times my pole. 20 times, it means it will be far from the origin. Far, it means less efficient. Okay, this is more powerful than this because here I have the steady state. Here S equals 0 or T equal infinity. Please ask me if you need to ask. Is this clear? Someone will say PC. Someone will say PC. Sorry. Yes, PC equal 1. No problem. You can take ZC equal 20. You will find S plus 20 over S plus 1. If you add this, when you put S equals 0 at the steady state, you will find same thing. This is also correct. Another also correct. It depends on your assumptions. Yes, please.
Yes, can I choose any number that I want?
Of course. I will check just the ratio. Yes, another question. The ratio has to be 20. Who wanted to ask? Also. Ask, even if you didn't study, ask, there is no issue. Fine. So, if there is a question, I will ask you to design lag compensator to improve the error. Let me say by 5 times. Find the or design lag compensator. You will say, okay, my 0 is 5 times my pole. If this is 1, this will be 5. Okay. Good. This is a gift. Discard. Now, what do we have also in the questions?
Doctor.
Yes.
If it was lead.
If it was lead, yes. You check what is written in lead. Go and check in lead. What we have done, we have just in the lead, we are not working on the error because lead is improving the transient, right? So we are improving the phase margin. Look here, we are improving the phase margin. And normally this is long question. If I will ask you to find system before and after adding the lead, maybe there will be a question for implementation, but not for the performance. Okay. Because you can see that you need to improve. Okay, maybe there is a question, what is the effect of the lead? But bringing a question, it's 2 times body plot and it's time consuming. I don't bring like this. Okay, if I told you the lag, it means I will bring lag. Almost, if I will bring, it will be lag. And if there is something about the lead, it will be implementation. Okay, and the implementation, let's see. Listen, in the implementation of, let's cancel something. And the implementation, what we have, implementation, you active circuit. Okay, this one cancel, no need. This one cancel. Implementation using active. Implementation of lead lag or lag or lead. This is all cancel. Okay, good. Implementation Using passive, yes. Lead lag, this is cancel. Leave this. It will be either this or this. I will ask for implementation. Let's select from now. Which one is easier? If I will bring one realization, tell me which one is having easier equation?
Lead,
This
I
one?
think.
Huh?
Lead, I think.
Lead.
Doctor,
Okay. Huh?
Lead.
do we have to include these equations in the summary, or you will bring it?
It's up to you. If you want it, you need to include. I cannot. This is why I gave you this option. I've told you have A4 page. You can write whatever you want. Okay.
Allah.
You can write whatever you want, because I will say something. I will say something. If I will bring, listen, if I will put this in the paper, I cannot give you marks by writing these things. You agree or not? I cannot put this on the question, and when you write this to me, I give you mark. I cannot. Isn't it? If you want, I can include. Tell me, doctor, we want you to include. And don't give us mark for writing this. We need only the answer. It's okay. Deal.
No.
Sorry.
No,
What do you want?
No, it's fine. We will put it in our.
Okay. But I will also listen to me. I don't seek the difficulty for you. If I am focusing on this, if I will bring design, I don't bring design lead. I will bring lag. That's it. This is why what I am discussing, it is the most probable coming. I don't hide something. Otherwise, why I am doing the revision? I can hide it from the beginning. There is nothing. I don't need even to hide. If you understand, get full mark. What is the issue in that? I will be more than happy. Good. There is also a question. There is also a question. Okay. For example, there is also a question about design. Look to this question. Discard. This question is, you have this system and you need to design how can I add this? Okay. So there is a question. I will take it as a snapshot. Okay. It is a simple question, in fact. It's a simple question. Look to this question. Look to this question. Find K value. Find K value to get phase margin equal 50. Find K value to make phase margin equal 50. Again, it is.
دكتور ما يبين السؤال عدل شوي لو تركب فوق. بس على فوق الصفحة لأنه ما يبين عدل.
No, it is cut. This one I don't need it. I need only this one.
Okay, تمام.
It's okay. I need only design K to make phase margin 50. Okay, this is a question. Who can give me an idea? I will give a bonus. This one, is it solvable? Yes. It's about what? About phase margin. Okay. Question about phase margin.
And find WGC.
What is the phase margin, by the way? Phase margin equal 50. When we find the phase margin, we find it. Okay, what is the equation? Phase margin equal. Phase margin equal.
80.
The negative angle that we can add to the system, right? So that is the angle of J omega minus 180. This one. Isn't it? What is the equation of phase margin?
Oh,
It is
Doctor, 180 plus.
180 plus. 180 plus this one. Okay. Fine. It's 180 plus. Okay. Okay, what is the angle here? Okay, we don't need. So the angle is tan inverse, imaginary over real, minus, what is the angle in this one? What is the angle here? I have two poles at the origin. Each pole is giving us how much? S.
Minus 180.
Minus 80.
Very good. S, the angle of S minus angle of S. This is minus 90, this is minus 90. So this will be minus 180. Okay? I have a plus 180. Phase margin is 50. Okay? I will find omega. I will find the angle.
But
The requirement that the
taking,
phase margin.
by taking tan.
Listen,
over-
sorry. Listen. Listen. One thing. What it does mean phase margin, the definition of phase margin. Where I said phase margin is extra negative angle that we can add to system before reaching what? 180, minus 180, or before getting unstable. Do you agree with this definition?
Yes.
So it means that this angle, how much? The angle of G equal, if the gain margin is 150, it means it is minus 130. Do you agree?
I didn't get it.
Okay. What is the phase margin? Phase margin is the negative angle that I can add to my system before reaching minus 180. This is the definition. Okay or not?
Okay.
I can
look,
put it. I can
use
put it in the
this definition.
Huh?
You just use the same formula 180 plus.
Yes.
Okay.
Because some of students they did not get it. I say it in a different one. I will write phase margin. Phase margin board. You will understand it. Go to the images. Look here. Shall I select something tool size big, large? Okay. Where we have this one is good. Let's see here. Phase margin is the extra negative angle that I can add to my system before reaching minus 180. Do you agree? Of course, when gain equals 0. When gain margin equals 0. Do you agree with this? This is the definition. Students, what is the definition of phase margin? When gain equals 0, it is the extra phase, negative phase that I can push before my system reach minus 180. Right or not?
Right, Doctor.
Correct.
Right.
Good. So I can understand that at this point, my angle is, if the phase margin is 50, it means this angle is minus 130. Do you agree or not?
Yes.
So my angle is 130. Good. I want now, if I have the angle minus 130, I will say, okay, what is the gain crossover frequency? It means for same omega, it will give me magnitude equal to 1. You agree or not? I want to find the magnitude. I want to jump to the magnitude, 1 or 0 decibel. Okay? We need, if you want this to be added, I can add it to the graph so you can always look at it. Let me add it. Let me add it. This one, okay. Let me add this one. Let me add it here, Control V, put it here and reduce it a little. Okay. Can this help you? Okay, I can put it here, no problem. So I will say, good, my angle minus 130, right? So what is the angle here? What is the angle here? The angle here, if you remove this with this, the angle we said tan inverse omega over 2 minus 180 equal minus 130. You agree, right?
Yes.
It means tan inverse omega over 2 equal to how much? 50. You agree? It means omega, I can find omega or not, take tan. Omega equal to tan 50 degree. This is omega which? Gain crossover. This one. Gain crossover frequency. So I will find that this value equal 2.38 radian per second. Radian per second. Because this is omega. We find it this value. Good. We have information saying that what is the gain at gain crossover frequency? What is the magnitude? What is the magnitude?
1.
1 or 0 decibel. You agree?
Yes.
So go to this one. Go to this one. Now the magnitude of G equal K.
Doctor, can you repeat the question that you asked before 1 minute, maybe?
Huh? Again?
Last question you asked, Doctor. Can you repeat it, please?
Last question, I said, okay, now we have found that at this point, the frequency, because you know, we said this is the minus 130. Now, at which omega? At which omega? Because I will tell you the truth. You have only phase margin. You don't have a lot of options. You need to go to the equation of phase margin, right? Okay, the equation of phase margin, what it will give you? It will give you the gain crossover frequency. You don't have anything else, right? You are an equation of phase. And this equation is function of omega. You have only the phase margin, so you obviously you need just to find omega. Even if you don't know what is next, okay, let's find omega. Then when you find omega, you say, this omega is the gain crossover frequency, because we find the phase margin at gain crossover frequency. But what is this useful for? It is useful because the magnitude for this omega equal to 1. So I will go and put it here, then I will find K. Is this clear? We don't have a lot of options, by the way. Clear, doctor. So I am giving you phase margin. From phase margin, let me take this in purple. Phase margin will lead you to gain crossover frequency. This will lead you to magnitude. This will lead you to K. That's it. So if we come here to solve, you want me down or here I write? As you prefer. So the magnitude, I will write that K J omega plus 2, okay, this one, over J omega square equal to what? Equal to 1 when omega equal 2.38. So it's clear, I can find K. I can find K, and I will find that K equal, you can check it, K equal 1.825. Now I have K, put it here. 1.825. What is asking me to do? What is the gain margin? Okay, gain margin when phase equal minus, what is the gain margin in this case? The gain margin, no, I don't think we need to find the gain margin because we are reaching here. When we are reaching the 180, you can find, but this is not the true figure. Okay, then you can find the magnitude. Now you can find the magnitude because you have K value. That's it. That's it. Again, this is a way of mastering. Now there is a question. Is all the questions are coming like this? No, I will not bring. But why this question? This question is for A students. Those who are willing to get A, I bring this one to distinguish. If you solve this, you can consider yourself in the A students. Okay, but again, I will not give 10 marks for this. Now you ask me how much I will bring out of 40. I can give 6 marks on this. I give 6 marks for this. Okay, usually when I bring a questions, 6 marks for this question if really the students is brilliant and deeply understanding the concept. Okay, so if you are trying to jump, you say, oh, this is difficult, you will repeat. Don't say bad things and repeat them. Don't put wrong program in your mind. Say always there is a solution, and the solution is always available in the lectures. Where are my rules? Here, the solution. This is the key. Okay. Now,
Victor?
yes.
آخر شيء قلت then if you find K, you can find what?
You can find the gain margin, because in the gain margin you need to find the gain. You cannot find the gain if you don't know K. Here, when you have 180, you will go and find the gain margin. In the gain margin you need K, otherwise you cannot calculate. So this is normally what do we have? The remaining things are simple, nothing. Direct, straightforward. Okay, remaining things are straightforward, like what we have taken. PID controller, simple. There is a question that you find PCR and you find KCR, and you have the table 0.6. This is K P, and you have K. I don't know, KD and KI. This is KCR, and this is PCR over 2, and this is PCR over 8, if I remember well. Okay, that's it. These are the types of. Now let's cancel something. Let's cancel something from the lectures. Okay, from the beginning, what we need to cancel? What we need to cancel? Here we have already cancelled this one. And the realization, look, PID realization, I don't think it's good to bring.
Doctor.
It's taking time. I want PID design. This is good. PID design coming almost, huh? Don't tell me you said coming and almost, because I did not set yet the questions. Here, I will not bring implementation for this one, maybe. What do you prefer, implementation of compensator or PID? What do you prefer?
PID.
PID.
PID is better.
PID, okay. If I will bring PID to get correct answer, I will give you the assumption. I will tell you assume C1 equal. So the correction will be unified for everyone. Okay, yes. If I will give you this, normally all of you should find these values. Okay, realize. Let me write it here. Realize PID. Yes. Realize PID. Okay, there is realize PID. There is design PID. There is lag compensator. I was looking to implement lead, but okay, there is no problem if you want the implementation of. Can I regroup, realize, and design PID in one question? Design and realize. Can I? Like
Yes.
I will tell you design, and the design, suppose you will find this one. Then I will ask you to realize.
Separate
Yes.
questions is better, Doctor.
Huh?
Separate questions is better.
You will get a lot of questions if we make them separate. I just want to simplify. By the way, suppose one of the students is finding this wrong and do the realization. He will not get 0 for the realization because this is wrong. I will follow also the steps. Okay, so it depends on the correction. Okay. Okay. What do we have?
It won't be long if you add realization.
Huh?
The question will not be long if you add realization and implementation. Both.
Because the students said we don't want realization of lag. They said we want PID realization. So we have designed PID, and you are asking for realization PID. Imagine what will be the question. It's the same question. Design and realize. But if you tell me we want realization of lag, it will be separate. Okay.
Doctor, okay, the tuning example is okay, but can you, for example, give us the closed root transfer function or the omega without using the route table again? We are using the route table in the root locus and for the design example, right?
I didn't get your point. It's long. Make it short.
For the PID controller, if we are adding the design with the realization. For the design, we need to find the closed loop and find the
Why? Stop. Stop. Why? You have this question here. Where we found this card? Where we found where is this? The PID. We have this PID.
Slide 13,
listen, this
slide
is
13.
PID. You have the transfer function. You go directly using these equations. You have these equations. This is the PID. So where is the closed loop? I didn't see the closed loop. You have this equation. You will make analogy. This is Kp. And this is Kd. And this is Ki. Where is the closed loop? Have this one. You say, okay, this is the Kp. And Kp equal to this. If you go back, Kp is this, as I have told you. This is Kd equal 1. Okay.
Sure.
So where is the closed loop? No closed loop. You just make analogy of parameters. Okay. Is this clear? So there is no closed loop. I didn't see the closed loop.
No, Doctor, I meant you said just before that you are going to include something, a question before this question, to find
question
the
of design. Design. Yes. There is a design.
Yeah. For the design.
It means that
for this design example, for slide 13, for example.
Okay.
We are going
you mean this one? No, this one is not coming. Sorry, not this one. We have two approaches. Who is this speaking? Who's speaking?
Zahra, Doctor.
Zahra. We have two approaches, theoretical and the practical. I will bring the practical. The practical,
okay.
I will give you like it has found for this system. It has found for this system. Where is this? This one. No, this we have the transfer function. I solved one that we. Where is the question? I solved one question.
You are giving us, for example, a graph to find the PCR from it and the KCR rather than doing the rough table, right?
Yes.
Oh,
where is the question of the graphical solution? I remember that I have solved one.
You just explained it. I don't have the question. You just explained it in your notes. That's it.
Where is it? I don't find it.
Not here in the whiteboard. You explained it during the
No,
lecture.
it has to be here. It has to be here. I remember there is a question here. I remember there is a question here. What's this? I have to check the slides, or I have to check what?
Victor, what are you saying? That you will give us a circuit that we should find the TF, then from it we find all of the KP and Ks, that stuff? That's what are you saying?
I don't hear you. You are speaking only to yourself. Raise your voice. Look, the question is coming like this. I will tell you for an unknown system. Okay. Suppose this is unknown. For an unknown plant, it has been found that when we are changing K, I will put here only K like this. Remove this. We find this response when K equal 10, suppose. So you will say this K is KCR, and you will calculate this. And you will say this is PCR, and then you will go to the table. I don't ask you to, I will not give you this transfer function. Okay? So practical approach. Clear? Zara?
It could be possible also to write an equation for a sine wave, then we can find from it this requirement, right?
It's okay. If this or written, what's the problem?
Yeah, okay. Got it.
Victor, how to find PCR?
Huh?
How to find PCR?
This is the time. PCR is the time. You have a wave. You need to see what is this here from here to here. What is this distance? We have solved.
From peak
I'm
to
sure, but I don't know where is it. It has to be here. For example, here you have PCR. If you find either the equation or either, but what I discard? Why there is no this transfer function? This question. I remember this very well. I solved in my lectures. I solved this in my lecture, but why I cannot see it now? Huh? Okay, let's open the PDF. I will search in my PID. Where is this download PID? Still unable to understand why this is not given. I don't know. But however, the concept is clear that you can find the oscillation period. Okay, it can be, where is the slide? This one. Okay, it can be given like this. For example, the output is 10 sine 2 pi t. Okay, the output when k equal 10 is like this, or I will give it like a wave. Okay, there is no problem. Or we can put it in MATLAB. However, what we will get, where is this one? Yes, what we will get is this is omega t. So omega equal 2 pi over PCR, 2 pi over t, PCR in second. So PCR equal 2 pi over omega, and 2 pi over 2 pi. So this is 1, that's it. PCR is 1, so this is 1 second. If you have it from the graph, you will find 1 second, or if you have it from equation. Okay, good. That's it. That's it for now. I wrote realization PID design practical approach. So I give a plot or equation. We have a lag compensator. We have another topic. It's root locus. And we have gain margin. Listen, Nyquist you ignore, leave it. Okay, study only BOD. Is this clear? So BOD, we have only BOD. Let me finish. We have BOD, gain margin, and phase margin, these things. Okay, or find transfer function from plot. Okay, we said root locus. We have lag compensator. Lag is already including error. Root locus is already including route criterion. Okay, what else that we have? I have what of the topics that we took? Who can remind us just the topics? Huh?
PID.
No, we already said design and realization. I just want to see what we have of the topics.
We have the block diagrams.
Block diagram, yes. Block diagram reduction. So what I will bring in block diagram reduction lectures. What I will bring from the block diagram reductions. Let's see here, introduction, physical modeling. Modeling, nothing, this we know, it's old. Or you want a question or modeling? Introduction, examples, block diagram. Okay, block diagram reduction. I don't like it.
Block diagram.
Because it is time consuming.
It consumes time.
Yeah, it's fine.
It consumes time, but you know, if I brought it to you in the midterm, I will not bring. But if I did not bring, I must. Because as per the regulation, everything should be brought at least once. So I think I brought for mechanical students block diagram, right? Mechanical students.
Yeah.
So you will not get block diagram. Mechanical students, you will not get. I will write it here. Block diagram only for EENG department, because you already. I will write not MENG. Okay. Now what I have frequency response. This one state. This you cancel. State space analysis. I will not bring. Okay. What else? We have about zeta and omega n. Okay, I will make it simple. I will try to find simple question, second order system. What I will write, this transient response. What we do in transient response, I brought for you design for a transient, right? Students, electrical, I asked you to design. Yeah. To find this data, this omega, and it's also for mechanical, right?
Yes.
So yes, if I will bring a question, it will be direct. I will give you a system, and I will ask you to find percentage overshoot and the rise time, settling time, peak time. These things. I will make it direct.
And Doctor, also transfer function.
Yes. What about it?
It's with us also, or you will not bring it from it?
What the transfer function? Which one? Which one here?
And for take off and so on.
I don't hear you well.
It means block diagram, Doctor. Take off.
Yes.
Block diagram. If block diagram reduction for electrical, not mechanical, because you got a question in the midterm, right? That's it. No need to check again.
Doctor, you cannot bring the physical modeling rather than the block diagram?
Because physical modeling is really something I don't have, let me say, I can't maneuver in this. I don't have a lot of options. It's the simple question. There is no point in bringing this. What you will get, this is physical and dynamical system. Okay, what you will have from this? This is equivalent to this. That's it. What else? Analogy. Tell the analogy. I brought something like this. Tell the analogy. I think I brought. That's it. We will not repeat it. I will bring the last question about system, real system, and you tell me which is the correction, decision, something like this. Maybe I will bring a question similar to this. Okay. I will give a question.
Doctor, you brought it also on the midterm.
But this is important. This is the concept. We need to emphasize on this. This is the concept, and I have to. Let's check one thing what I brought. Okay, that's it. There is a question about this, and that's it. I think now the questions are clear. Let me write it. Let me write it in a Word file. Design and realize PID controller. Practical approach. Design lag compensator. So this is only design, don't realize. Okay, I ask you just to design lag compensator to improve steady state error by X times. Okay, we have also root locus. Body plot. So I have two things.
Doctor,
Find K value to get X phase margin.
Doctor,
Just let me finish. I'm writing, I'm concentrating on something. I don't want to lose my idea. Drive the transfer function. Open loop, which is G of S. Okay. And I have also block diagram reduction. Electrical. And I have performance of second order system. So if I will tell you the performance, you have how many parameters, how many equations? I think rise time, TR, TS, overshoot, peak time. That's it. Or there is another thing.
Zeta.
No, it is given in the system. That's
So
it.
that's
Huh? Transient, I will say transient. So it will not consider the error. Transient performance. Okay, we need to bring a question for also identify the elements of control systems. The shown. Which was this? Shown. Control system. Okay, identify the elements. Good. If you will say there's feedback, it means this is a closed loop. That's it. Now, I think fine. For the mechanical, you need to give me something because this is for electrical. Mechanical, guys, do you have something that I can put here for mechanical? Mechanical, guys, you select something for you from the topics. Let's go and check here. Where is this one? Are you with us? Mechanical.
Yes, Doctor, I'm
Yes,
searching.
sir.
So what we bring? What we bring? Mechanical.
Doctor, you brought the root locus. You will bring it again in the final.
Yes, because the root locus that I brought didn't contain the breakaway point. I make it simplified.
Is it
So
fine
what should I bring here for you, students?
designing K, for example, for certain error?
For certain error. It's okay. We'll see this. We'll see. I can adjust. There is no problem. So yes, those who are willing to ask what they wanted to say.
Doctor, can you go to the word again?
Yes.
About second one, design lag compensator to improve steady state error by X time. Do you mean X as a percentage or as a multiplication? That we have
No, X times. What it does mean times? Multiplication.
Yes, so not as the slides example.
2 times. What you understand by 2 times?
Multiply. But I got confused with the example of slides, Doctor.
Why? No. In the example of a slide, this is not percentage. It is also times.
Yeah, but you multiply by 1/20.
1/20, this is the ratio between poles and zeros, and this is different from the error. It is not the error. You divide because you want to find the ratio between pole and zero, right? But here I am talking about error.
Yeah, Doctor, you multiply by 1/20 the error, the same error. That's what I remember.
Yes, you multiply by in order to reduce it to 20 times. That's it.
Oh, so the same concept.
Listen, you are mixing 2 different things. Where is this draw? You have your where can I write here? Let's take this one. Or let's go back to the same question. Where is it? This one. Find this. Yes. Okay. You have in your system compensator. This is the lag. And you have your system. Okay, right? So your error of system equal, suppose, X. I want you to design lag so that error total, it means system plus lag equal X/20. Now we said improve by 20. I will tell you improving the error is to reduce it. It means this one will be 20 times this one. But which one is the improved? With the lag. With the lag. Okay, so for example, you want to purchase, suppose this is like money. Okay, error and money same, we want to minimize. You go and you purchase something with 100 BD. I will tell you, find a way to improve the cost 20 times. improving the cost 20 times, it means that you will divide it by 20. And
Yes,
then you will tell me the
it's
cost
clear.
now is 5. Now the cost is 5, okay. Now the cost is 5, it's improved 20 times compared to this one. This one is, let we say, degraded 20 times. What is the opposite of improve? Huh?
Reduce.
What is the, huh?
Reduce.
Reduced? No, not reduced. Okay. So if I want to improve the error by 20 times, it means I want to reduce it by 20 times. But it is not literally. You are trying to understand things literally. Understand the blocks. If you will add this block and this one, the error you will get here, the error, your G of S will give you X. You want to multiply it by something to reduce it by 20. So logically, the ratio when S equals 0 has to be 1/20, like this. True or false?
Yes.
And this is giving you the ratio equal to 0.2/0.01. This will be 20. If you will add it here, you will take the gross or the overall transfer function, open loop, sorry, in cascade. It will be like this, because this you cannot change. This is your system. This is why you add compensator. So you have improved. Okay. I don't know how to explain it, but for me it's clear.
Yes, Doctor, it's clear. It's clear. It's clear.
Okay.
So, Doctor, you will bring for us designing K for certain steady state error.
No, you are exempted. I don't think so. No need. That's it.
Okay.
What I wrote here is okay.
I want to make sure what's the additional question you will add.
Maybe there is no additional. Who knows?
Hey, you said you will add another than block diagram.
I said this. I said, but not necessarily. Almost. Maybe I will not bring. Okay.
Okay.
Good. So you have this paper. Mobile is not allowed. Smartwatch not allowed. And you write your own notes. You come with your own notes, printed or not printed. Okay. You want me to give you some formula, something? I don't know. Or no need. I don't know what should I do. But if I will write something, I will not give you marks for writing this.
Doctor, we will give our formula.
No need, Doctor.
This you can gain marks. Okay. I will bring like this. Of course, not all the question has to be difficult. I don't believe in that. I don't like to challenge my students. I just want them to understand the depth of the topic. Okay. If they will understand this, okay, no problem. Go and tell that you have seen the question. This is the questions. What is the problem? There is no numbers. If you master this and you deserve A, congratulations. I am more than happy. I have nothing to hide.
Doctor,
Okay.
so right now the total questions in the final will be how much? 4?
4, but I will put a branch like, okay.
Yes.
I will put some branch. Here in root locus, we said either plot or not necessarily, or find K to get this root. Get S equal, like, for example, S equal, to get S equal, I don't know. What should I put to get S equal X on the root locus? The root locus, I don't know. Okay, this is fine. You snap it if you want. Compensators. Compensator.
Doctor,
Okay. Huh?
will you ask us to plot body plot?
What is the difference if you know how to plot or if you find the transfer function? You need to ask the right question. If you understand body plot, it doesn't matter for you. It doesn't matter.
Thank you, Doctor.
Okay, that's done. After this, you will find your marks. I have finished grading everything. You will see your mark. If there is an issue, you tell me. If there is a promised bonus, you tell me.
Doctor, I have I think 1 or 2
that's
marks
it.
bonus.
Huh?
I have 1 or 2 mark bonus.
When I will post, write to me. I will check. Just after this meeting, I will post this on Teams. Okay, dear students.
Yes,
Thank you,
Doctor.
Doctor.
So much, Doctor.
I just want to tell you one thing. The level of understanding the course and the materials, to my knowledge, is as good as in USA. Is as good as in any international university, because I am collecting a lot of ideas, lot of references, lot of tools. So this course really, you are taking the depth of understanding physical, behavior, dynamics, improving the performance. And this is really something that I am happy, and I am happy also because there was a very good interaction and participation during the whole lectures. Thank you very much, dear students. I am happy to have you in my batch for this semester.
And we are happy to have you as our doctor.
Inshallah, don't hesitate even to ask. Q&A is still open. You can post in the Q&A to get the answer of your questions. I will post right now your grades, inshallah. Good evening and assalamu alaikum wa rahmatullahi wa barakatuh.
Alaikum assalam.
Thank you, Doctor.